Lesson 3 is on multiplying radicals, which is actually easier than the adding and subtracting radicals. I think of radicals a lot like fractions. So with fractions, you can't add fractions unless you have a common denominator. With radicals, you can't add them unless you have a like radicand. Like what's underneath the radical symbol has to be the same in order for you to add them. When we multiply fractions, we get to multiply just straight across, top, top, bottom, bottom. When we multiply radicals, it's the same thing. Multiply those radicands together, multiply the coefficients together, and we're done. There's, well, not quite done. You can simplify, but for the most part, that is really all there is to multiplying radicals. So what I want you to do is take a couple of minutes and use your calculator to tell me which of these 5 statements are true and which ones are false. So if I look at these statements, the square root of 2 times the square root of 3, does that equal the square root of 6? Yes? Okay. 2 root 5 times negative 4 root 3, does that equal negative 8 root 15? Okay. Root 2 times the cubed root of 4, does that equal the cubed root of 8? No. Okay, so this one's false. D, 2 times the cubed root of 10 times 3 times the cubed root of 7, does that equal 6 cubed root 70? Yes? And then the last one, 4 cubed root 5 times 7 square root 6, does that equal 28 6th root 30? No. Okay. So based on these results, if I had to write a rule to multiply radicals, what could I say? What do I do? So what do you notice about the radicals that were true compared to the ones that were false?
You can't have like a third or like a cube root multiplied by a square root.
Okay, so the indexes need to be the same. That's the first thing. So when the indexes were the same, such as in A, B, and D, what can I do then?
Multiply the coefficients.
So multiply coefficients together. And multiply, what do we call the part underneath the radical sign?
Radicand.
The radicand. Good. So this index is needing to be the same. That's not that much different from when we were doing the adding and the subtracting of radicals. They needed to be the same in order to simplify those as well. So if we look at class example number 1, I am going to give you a couple of minutes, and I want you to see if you can do these 4 questions on your own first, and then we'll look at them together. So let's take a look at our answers. What is the square root of 8 times the square root of 8?
Square root is 64.
And what does that simplify to? 8. So what can we say happens when I take a radical and I multiply it by itself? So without using a calculator, what would be the square root of 1124 times the square root of 1124?
1124.
Yeah, so squaring it cancels out the square root. We call those inverse operations. It's like if I add by a number and subtract by a number, it cancels out. Multiply by a number, divide by a number, as long as it's the same number, they cancel each other out. Okay, 4 root 5 times 3 root 6.
12 root 30.
Okay. And then what I should do with 30 is just take a look at my perfect square chart and see if I can divide 30 by 4, 9, 16, which I can't, so that is simplified. Okay, 4 root x times 3 root y.
12 root xy.
Thank you, Rachel.
Someone else says that and it drives me crazy.
She says the first two times.
Okay, negative 2 root 8 times 5 root 12.
Negative 40 root 6. Or do you want the non-simplified one?
Let's do the non-simplified first.
Negative 10 root 96.
Okay, and then what did you do with 96?
It can be simplified to like 16 times 6. And then figure out like the forwards times 5.
And then that's how I get my negative. Can't remember, did I show you doing this on the lesson where I put it up above? Yeah, it's just, then I'm not taking as many steps. Okay, good. Okay, so try looking at class example number 2. The difference between class example 1 and 2 is I'm now dealing with multiplying with binomials. So when we do this, we're looking at the distributive property. It's the same as if I asked you to multiply 2 times 4x minus y. You would take the 2 and multiply it to both factors inside. So that's what we're going to do, is take the root 5 and multiply it by both factors. So again, take a couple of minutes to go through these questions and see what you can do on your own. So if I take root 5 and I multiply it by my 2 root 10, I will get 2 root 50. And then when I take root 5 and multiply it by negative root 5, it's going to give me a negative answer. And we talked on the previous question, if I take a root and multiply it by itself, it cancels out that root. So I would get just 5. Then I look at 50 and I check, can I divide 50 by a perfect factor? Which one can I divide it by? So then my 25, the square root of 25 becomes 5. So then my final step would be to multiply the 2 and the 5 together, and I would get 10 root 2 minus 5. And you could actually check this out on your calculator. You could type this in, root 5 bracket, 2 root 10 minus root 5 bracket, see what you get for a decimal approximation, and then type this in, and the decimals should match up. If they don't, then you might want to take a look, double check that you've put it into your calculator correctly, and then go back and double check your steps. So if I look at question B, there's 2 ways that I can do question B. I can just multiply it straight through. So 2 root 5 times 3 root 45 gives me 6 root, I think it's 225, right? Minus, and then 2 times 8 would give me 16. The root 5s are the roots are gonna cancel each other out, so I'll be left with just 5. And then the last one would be plus 6 root 100. Can I simplify the square root of 225? It's 15. So it's not 6, or it becomes 6 times 15. And the common mistake that I see with this is all of a sudden students will start writing this. Because they think that the radical, that I can't just get rid of the radical, it has to be somewhere. Well, no, if the radicand is a perfect square, when I take the square root of that perfect square, the radical will be gone. So it would just be 15. And then 16 times 5 is 80. And what happens when I go to simplify the square root of 100? I get 10. So 6 times 15, I get 80 minus 80 plus 60, which equals 60.
I think it's.
Did I do that wrong?
Yeah, I think it's 96 times 15.
Oh, yeah. Sorry. So then my answer should be 70. That makes more sense. So with C, I have the distributive property twice. So I have to take the 2 and multiply it to both parts inside. And then look at this as a negative root 2. So negative root 2 times negative root, or times root 6 will give me negative root 12. And negative root 2 times 10 would give me negative root 20. And then I look at the 12 and the 20. Does 12 contain a perfect number as a factor? And does 20 contain a perfect? 4 again, so 4 times 5. So then I have still my 2 root 3 and my 2 root 5. Then my root 12 will become 2 root 3. And root 20 will become 2 root 5. And then with my adding and subtracting rules, I can now collect the like terms. 2 root 3 minus 2 root 3 would equal 0, so that's gone. And negative 2 root 5 and negative 2 root 5 would be negative 4 root 5. And finally, the last one, we deal with variables. So negative 4 root a times root a will leave me with negative 4a, because those roots are going to cancel each other out. And then negative 4 times negative 9 would be a positive 36 root ab. So now if we take a look at class example number 3, we're going to write and simplify an expression for area. How do I calculate the area of this shape? Ignore the numbers. How do I calculate the area of this rectangle? Length times width. So the area is going to be the length, which I can put as 4 root 6, and the width, 7 minus root 6. So this time when I go to multiply it, I have two binomials. So when I'm trying to use that distributive property, I have to take the 4 and multiply it by both parts inside. So I get 4 times 7 is 28. 4 times root 6, negative 4 root 6. And then I have to take this positive root 6 and multiply it by both terms in the other expression. So root 6 times 7 will give me 7 root 6. I put the coefficient first. And then root 6 times negative root 6 would give me negative 6, because the roots would cancel out. We also call this FOIL. Multiply the first terms, the outside terms, the inside, and the last. But really, FOIL is using the distributive property. Collect my like terms. 28 minus 6 is 22. Negative 4 root 6 and 7 root 6 gives me 3 root 6. How do I calculate the area of B? I'd have to square it, or it's the same as length times width. The only thing that I'm going to talk about is these numbers in here. So if I started by squaring it, so that means I multiply it by itself. When I go to start multiplying this stuff out, what's going to happen when I multiply 27 by 18? I'm going to get a really big number. So in this case, it might be worth taking a pre-step. And that pre-step, look at 18. Does 18 contain a perfect square? 9 times 2. So the square root of 9 is, and 3 times 2 is, so I can take 2 root 18 and write it as 6 root 2. Does 27 contain a perfect square? 9 again, so 9 times 3. Square root of 9 is 3. So instead of root 27, I can now write 3 root 3. So now if I go to multiply this by So now if we look at this and we start multiplying it out, 6 root 2 times 6 root 2 gives me 36 times 2, because the root 2 and the root 2 would give me 2. And then I take my 6 root 2 and I multiply it by my negative 3 root 3, which will give me negative 18 root 6. Now I start looking at this negative 3 root 3 and I multiply it into the other expression. And I get another negative 18 root 6 and a positive 9 times 3. 3 times 3 is 9, and then the 2 root 3's would give me 3. 36 times 2 is 72. The two negative 18 root 6's are going to combine to give me negative 36 root 6. And then 9 times 3 is 27. Last step would take the 72 and the 27 and add them together. Now, the biggest mistake that I see with this type of a question goes back to what you guys told me at the beginning. I can take the side length and I can square it. And the most common mistake that happens when we square it, we square the first one and we get that 72 eventually. We square the last one and we eventually get that 27. But until we get more proficient at looking at these and expanding them out, a lot of students forget the fact that there's those middle terms, that I have to multiply this by that and these two terms together. And so they forget that middle term all the time. So if I expand it out and I write it physically out twice, I'm less likely to make that mistake. Okay, so let's see, what can I give you for questions? I will reduce the number of questions that I give you just because I know that we've already done several examples. So question number 1, let's give you D and I. And then question number 4, D. Do question number 5. Question number 6B. D. 8A. 9D. And 10A. Actually, not 9D. Let's make it 9C. So 9C. And then 10, what did I say, A? Okay. What we're going to look at is multiplying what's called conjugate binomials. So if we take these two binomials and we multiply them out using our distributive property, root 5 times root 5 is 5. If I multiply the outsides, root 5 times root 2, root 10. Negative root 2 times root 5, negative root 10. And negative root 2 times 2, negative 2. So I get 5 minus 2, which is 3. And what happens to my root 10s? They cancel out. They equal 0. Okay, so now if I take 2 root 7 plus 8 times 2 root 7 minus 8. So 2 root 7 times 2 root 7 would be? 14. Not 14. 14.
49.
Yeah.
4 times 7.
Or 4 times 7,
Yeah.
right? Because the 2 times 2 would be 4, root 7 times root 7 would equal 7. 2 root 7 times negative 8 would be negative 16 root 7. And then I get a positive 16 root 7. And 8 times negative 8 would give me negative 64. So I get 4 times 7 is 28. These two terms would equal 0 again. And what is 28 minus 64? Pardon? Thank you. So if you notice with my binomials, what do you notice about the two expressions? Or each term? Do they look the same? They're the exact same except that middle term. And what happens when I multiply them together? Their middles cancel out. Last year, what did we call this? This was a difference of squares. When we were doing our factoring last year, this was a difference of squares. And in a difference of squares, my middle terms always canceled out. So if I'm multiplying by a conjugate, and I recognize that it's a conjugate, all I have to do is multiply the first terms and the last terms. I don't need to worry about the other part. So what I want you to do, we are going to write the conjugate and then multiply it. So if I have the expression 4 root 6 plus 3, what's the conjugate going to be? And then when I go to multiply this stuff out, 4 times 4 is 16. Root 6 times root 6 becomes 6. And then 3 times negative 3 would be negative 9. 16 times 6 is, and 96 minus 9 is 87. Okay? So if I look at B, my first term is negative 3 root 11 plus 2. So what's the conjugate going to be? And what about the negative 3 root 11? Will it stay as a negative 3 root 11? Yes. It's only this sign here that changes. Interesting to have on video. So negative 3 times negative 3 will give me a positive 9 times 11. And then root 2 times negative root 2 will give me a negative 2. So 99 minus 2 will give me 97. So what's the conjugate of the last one? Yep. So when I take 5 root x and I multiply it by 5 root x, what do I get? 25x. And then root y, or negative root y times y. That's it. So, let me add question number 13, B and D. And 14, 15, and 16.